Hi everyone, my name is Piotr Zaniewski and I will be talking about virtual clusters. But before we start, let me know if you're involved in maintaining Kubernetes clusters in any way or form, managing them. Right. Are you involved in multi-tenancy or providing various clusters to either your teams that you support or customers? Quite a few as well. All right, so. And one final question, have you ever experienced an incident while upgrading anything on your cluster? Wow, only a few people. This is good. You haven't been exposed to craziness of Kubernetes. Okay, great. So as I mentioned, I work at a company called vCluster. If you haven't heard about it, we like Kubernetes so much that we put Kubernetes in Kubernetes. So this has all kinds of crazy properties, but let's take it slowly. So this presentation has multiple points of failure. Anything can fail at any point in time. This is running on my home lab and it's gonna be crazy. But later you can actually run it yourself if you have an Nvidia card. You can do this all on your PC. So I set up the cluster already. So what we are going to do first, we're going to do a quick reminder. What is Nvidia KAI scheduler? Who works with Nvidia KAI scheduler or had a pleasure of deploying? All right, so this is really just a Kubernetes way of providing functionality around supporting AI infrastructure, whether it's inference time or whether it's training time. KAI scheduler is a way of saying, hey, I can take GPU nodes, GPU compute, and I can have a dedicated Kubernetes scheduler that will decide where the workloads will go, who will have access to them, and so on and so forth. So it has a few interesting properties. So fractional GPU allocation. You can share single GPU node among many workloads. That of course depends on the workload size and so on. It has queue-based system scheduling. It's aware of the cluster topology, and it also has various sharing mechanisms. It has been open source just lately in 2025. And it, of course, has a lot of vendors behind it that provide paid solutions. But the main takeaway here is that Kubernetes is really emerging the main infrastructure engine for AI workloads. We talked earlier today about various applications of AI that are more customer-facing or B2B facing, whereas Kubernetes, that we all know and love, obviously, is something that will run our workloads. And there are ways to do this well already. So this is the KAI scheduler itself. Now, this is the part of the demo that can backfire. So again, this runs on my local client cluster. And what we are going to do, we are going to find out whether my cluster has support for my GPU. In other words, whether my old Nvidia graphic card actually exists and the cluster can see it. So this is not production grade setup. This is just a demo, but it's interesting. If you have an Nvidia card, you can run it yourself. If you're interested how I'm doing it, this program is called present term, and I can present and execute commands in the same time. All right. So we talked about KAI scheduler. Let's talk a little bit about what is vCluster. Apologies for the bad resolution. Who has heard or used before? No one. Oh, one person. Okay. Or two, sorry. vCluster isn't really that difficult to understand. It's the ability to have containerized Kubernetes inside of a pod. Mostly we are talking about the control plane components. Why would you want to do this? The simple reason is that if you need to provide multiple Kubernetes instances, whether to your internal teams that you support as an SRE or a platform engineer, or you have to provide Kubernetes to external tenants, then you have basically two ways. Either use a namespace, which is limited, as you know. You cannot, for example, create global resources such as CRDs, or you can give them the full host cluster like an EKS or AKS. vCluster is somewhere in between. It provides an ability for anyone to have actual full-blown cluster inside of a host cluster. A little bit of an inception, but why it's cool is because it opens up ability to share certain services. As SREs, we can decide that ingress controller, or it's a better example nowadays, so maybe API gateway, we want to share it between a few teams, but some of those teams should use their own dedicated API gateway. So since you have ability to deploy global resources, you can have this mishmash of services. There's quite a few other benefits, of course, but in a nutshell, it is a fully certified Kubernetes distribution, and it provides this flexibility that fits all use cases rather than just 80%. Okay, so we have those two guys. We have scheduler, which you normally install in a host cluster, and you have vCluster. So let's talk a little bit about GPU workloads. Obviously AI, everyone talks about it, but it's a little bit more than that. So we have things like image generation, which is stable diffusion, video processing, development of frameworks like CUDA, batch processing. So there's quite a lot of instances where we would like to provide, whether our teams or external customers, ability to run their workloads on GPU. Now, regardless which workload we choose, and let's stick to LLM as an example, there is a shortage of GPUs. It's just a really scarce resource nowadays. Everybody's racing for it, and having a reliable GPU instances on demand is not as easy if you don't want to pay $30 for it. So let's have some fun and deploy something to our cluster. So I'm going to show you how this could work in an actual application where you want to deploy a web app to a cluster, and then you want to share this for various teams. Of course, the better example would be inference, but my Nvidia card is not going to do any inference on this computer. In real-time scenario, it would be something that is definitely more interesting. So we're going to wait a second while the spot is being deployed or not. This can also not happen. So this will not work, but don't worry about it. I'm going to skip this part for now. So let's talk about upgrading schedulers. So what's happened with the scheduler is that typically Kubernetes scheduler runs on the host cluster, right? It's an integral component of Kubernetes. And we have a scenario where Kubernetes takes any workloads, let's say deployments, and then decides where should it place the pod. So the scheduler will make this call, and then of course Kubert will actualize it. So if you do this on host cluster, then you have one scheduler. So imagine connecting new nodes, you have more GPU compute nodes available, and then you have only one scheduler available here. The reality of this is that if something goes wrong with this scheduler, obviously it affects all the teams. So the blast radius is really broad. And if you encounter an error, then the rollback might go well, might not go well. It's a little bit of an unknown. Depends how good your observability is, how good your procedures are for rollback. And the teams can be blocked on a single scheduler version. So what's the alternative? What can we do to do it? So the alternative is to run a scheduler that is essentially dedicated for team. Before we go there, just a little bit more at the risk. So as we all know, the downtime costs a lot depending on what we do. If we have a platform that processes high sensitive data and high throughput, the cost of downtime can accrue really quickly. So depending on what we do, this can be a lot of cost and this can be really difficult to maintain. One solution that we could look at is vCluster isolation. So think of having ability to have a virtual scheduler that you can use to schedule your pods rather than change the host cluster scheduler directly. So you can imagine this simply as having your production cluster with a virtual cluster inside of it, one or more. And this virtual cluster can use, for example, version 09.2 of KAI scheduler, whereas your production host cluster stays on different version 07. So you do this experiment, you do an A/B testing on your schedule. If it fails, no problem, you just delete your cluster and everybody's happy. So talking a little bit more about the risk, single scheduler controls the cluster. Any changes can affect all the workloads and we have no isolation. So don't be afraid, it's just YAML. You've seen lots of it. This is a way how we can configure virtual cluster to enable the scheduler. I'm not going to go through details, but you can read it yourself in the docs, and we're setting a few options here that create a virtual cluster. Remember, virtual cluster is a pod hosting Kubernetes controller, Kubernetes control plane binaries, plus a special component that we call syncer that synchronizes workloads between host cluster and virtual cluster. So this is a way of configuring it. And what happens when we deploy it, we have independent KAI schedulers, in this case, for each cluster, and we can have a complete scheduler isolation and the autonomy for other teams to do it. So let's see if this works. So we can see now this is a scheduler in host cluster. By the way, who uses and loves K9s? Wow, okay, fun. That's great. If you don't know K9s and if you work with Kubernetes, highly recommend it's the CLI that you see. You can connect to it and just check what's happening on your cluster, interact with it, which is pretty cool. So this is our cluster installing. Now, it's quite confusing if you haven't worked with virtual cluster earlier to kind of wrap your brain, what does it do? So real quick, the main components of virtual cluster are kubeAPI server, like normal API server component, syncer, which is a specialized component that's a secret sauce of vCluster. It makes sure that whatever you deploy in your virtual cluster is synchronized to your host cluster and vice versa. And this is something that you have a lot of control over. So I mentioned at the beginning that you can have services that are shared or services on the virtual cluster. Syncer is the way of implementing. And the open source version of virtual cluster comes with a SQLite. It runs inside of a pod, so it's fully reproducible. You can snapshot it, clone it, and do all kinds of crazy stuff with it. Obviously, we support etcd, external cluster or internal etcd. And as you see in this presentation, we are using a virtual scheduler, so we can replace the scheduler that comes with default Kubernetes. All right, so let's run this. We are essentially creating now another virtual cluster. So we are here connecting to our existing virtual cluster. So this is a simple CLI connect. So this way, our kubeconfig points now to the cluster inside of our cluster. It's a bit of an inception. We are connecting directly to a kubeAPI server running inside of our virtual cluster. And inside of this cluster, we are installing the KAI scheduler, just a regular Helm command. Anything you can do with a regular Kubernetes, you can do with virtual cluster. So we just deployed it like this. Let's see how it works here. So you can see now we are connected to different contexts. vCluster KAI isolated, that's a long name, for virtual Kubernetes cluster. So now you've got those two guys, so my cluster running and virtual cluster inside. And you can see this is a typical pods that got deployed with the KAI scheduler. Okay, cool. So we can do the same that we did at the beginning, deploying some random pods. So let's do this. What pods are those? Some demo pods, super simple. You can see there's a few annotations. We are saying KAI scheduler, GPU fraction 0.2%, 0.1%. So this is, think of it like limits in memory in CPU. We're essentially saying that this workload can only utilize up to 0.2% of our GPU capacity. And then we are using various other settings here to tell where and how we would like to run it. Okay, so this is already done. And now we can deploy all those queues again, now connected to our virtual cluster. And now we have two demo applications that just sleep. They don't do anything interesting, but they are here. Okay, so this was a quick demonstration how we could deploy alternative version or different version of a KAI scheduler directly onto virtual cluster. So imagine that this was our A/B testing. Something didn't go well. We didn't upgrade the KAI scheduler on the host cluster. We just did it quickly like this. One of our teams tested it and something went wrong, but we want to get rid of it. So instead of reverting it and instead of trying to remedy the fallout of the upgrade, we can simply delete the whole virtual cluster. So this is a change in way we approach Kubernetes when we use virtual cluster. Those are disposable, ephemeral objects. So normally, Kubernetes cluster in and of itself, all the saying pet versus cattle, it should really be cattle, but in reality, it's mostly pet clusters. We know their IP addresses, our prod or something. Whereas for vClusters, you really treat it as cattle and you can delete it. So you can see at the very bottom, about 40 seconds took us to delete the cluster. And now our experiment was safe. So different teams might have different requirements. So for example, you could have a ML team that needs a version of KAI scheduler a bit higher or lower. Research team might need different version, and the dev teams might need other settings on top of it. So you have this capability, whether you're supporting your internal teams as an SRE or platform engineer, or you're supporting customers, you can do this now. You can have this flexibility to support them in different ways. So let's create 2 virtual clusters in the same time. So you can see it's very easy to create and destroy Kubernetes clusters. So you can start thinking about this in a much more playable way. Normally, when we deploy Kubernetes cluster, unless we use EKS cattle and it's for dev test, we actually put some thought in it, and all it takes cost and time. Whereas with virtual cluster, you already have your tested infrastructure in a host cluster, and then you just keep throwing those clusters, and they can be disposable. They can, of course, run production workloads, but you can think about them differently. So you can see we have similar scenario here. I'm connecting to those clusters that we just deployed. And on one of them, I'm installing 0.7, and on another one, 0.9 versions of the KAI scheduler. So this is running, and now we can connect to them and apply the same GPU pods that we've seen earlier in the demo. So it looks and feels as if we are juggling a kube context, connecting to different clusters. And it's true, but they are not host clusters. They're not separate entities. All this happens inside of our single host cluster. Let's say it's a big EKS cluster that you have. And now you can see the benefit of it, where your teams or customers can suddenly coexist in a well-isolated space where you can harden your host cluster, and you can start giving virtual clusters that provide different capabilities. In our case, we are talking about KAI scheduler, but this can be literally anything. It's very flexible. So let's see how many virtual clusters. We currently have 2 clusters running for team beta and team stable. They are all operational and running, and we have here enabled our teams to move independently with the schedulers of their choosing. And of course, the blast radius is only limited to those teams. From this, it's easy to extrapolate cost benefits and other isolation benefits as you start moving to this space and say, oh, maybe I want to also have a team that has a dedicated ingress controller or a dedicated cert manager and so on. So those things become suddenly accessible and easy. So virtual scheduler is enabled on every cluster. KAI location is inside of each virtual cluster, independent per team, and we don't have a host impact other than having a pod on our host cluster and obviously deleting it. So let's see how this looks. So here we have all the clusters. So this view you've seen. So just to sum it up, what kind of journey we went through. So we started from a scenario where we had centralized host cluster with a single point of failure being a KAI scheduler deployed there centrally for other teams to use. And in a scenario where we would like to test upgrades as an SRE team, that's a quite big endeavor, and it can be risky. It could be hours of debugging or searching in logs of observability, making sure that we understand what went wrong. We were able to reduce it to just a few seconds or a few minutes using the vCluster. And again, there's no risk on your host cluster. It's a very encapsulated blast radius. Finally, rollback of bad changes. It can be quick if everything is nice, but I've had scenarios where deploying CRDs that manage external objects, think Crossplane or similar project, can backfire. So if you don't do this well, it can be a Pandora box that you're opening. Whereas with vCluster, this rollback simply means deleting the virtual. A/B testing is also very easy. We were able maybe to provide the change to the host cluster KAI scheduler, and then we can release a few virtual clusters, give them to various teams or testers, and they can test it safely. And then per team schedulers is also becoming trivial. And the GPU sharing, now if your team wants something special on top of GPU sharing, you can provide them virtual cluster relatively quickly, and they can just go and test it, and it does not affect any other teams. By the way, I mentioned earlier, the teams that use virtual cluster can have admin permissions there. This is desirable because virtual clusters are ephemeral, so they can install CRDs, they can install operators. You can, of course, limit all this, so it's all configurable. All right, this is going to delete all the infrastructure at home, and a little bit of links for the docs. Our docs have various scenarios, including the description of how you can install KAI scheduler on the production host cluster, not just on a demo like I did here. Join us on our Slack. We have a community Slack, as well as office hours every week explaining what vCluster is and what benefits it can bring. So I think I have 1 minute for questions.
Thank you. Very interesting presentation. I was wondering how much strain does it put on the host cluster? Do you need a lot of resources, or is it really light to run like multiple virtual cluster inside the host cluster?
A good question. So it's really small resource footprint, just a vCluster pod without any additional pods inside of it is about 200 up to 400 megabytes of RAM and negligible CPU. It's just a pod essentially with operator running. It's copying Kubernetes resources on each container. It's copying the binaries and it's running the sync. And what is also confusing, might be helpful also to your question, is that virtual cluster runs pods on the host cluster. So the pods are encapsulated to a namespace where vCluster runs. And if you give access to someone, admin access to kubectl, this person will only see the pods that are scoped to this virtual cluster, but they actually run on the host cluster. That's why observability or security becomes easier, because you use the same tools as you would use with other pods as well.
Okay, so the virtual cluster is essentially just a namespace where you have another cluster and it's isolated from the rest.
So it's more than a namespace. It has, inside of the pod of virtual cluster, you would have Kube API, you would have controller manager and other control plane binaries. So it encapsulates all of those. So you're actually talking to the Kube API in the pod rather than talking to the Kube API on your host cluster. And pods are the entities that vCluster manages for you. They are scheduled on host cluster, but everything else, secrets, config maps, they're actually stored in the etcd of your virtual cluster. That's why it's super easy to take any workloads you deployed, snapshot it, clone the whole virtual cluster, deploy it somewhere else, move it, because it has all the context from the running resource.
Thank you.